But basically what I'm doing is I'm making a reasonably strong salty solution, and I'm going to either pass that solution back through the filter, which will replace the sodium ions and regenerate it, or I'm going to soak the particles, water filter particles, in the solution, and that will do the same job. So the steps are, the first step is to dry it out, because if it's carbon and exchange resin mixed, you need to dry out the carbon. So you need to dry it out at about 100 degrees C. Well, if you put it on your radiator, most boilers and radiators are set to a temperature, safe temperature of between 65 and 90 degrees C. So if you've got a hot radiator and you just dry the carbon out on the radiator, what that does is that evaporates some of the impurities, and if you do some research on that, you can find out the exact chemical process, but I'm just generalizing here, of course. So here we have some sodium chloride, otherwise known as salt. So just coarse sea salt. Sats is the make, the brand. I've got no affiliation with them, just showing you this video for demonstration purposes. And what I'm doing is I've got a washing up bowl. I've cleaned it, but it's got a few scratches on it and stuff, but it doesn't have to be like surgically clean or industrially clean. I've just got a spoon and I'm putting, obviously I'll be doing it with two hands normally, just putting some sea salt in the spoon. I'm using two to four dessert spoons of sea salt, basically table salt. I use sea salt because I prefer it. I think it's more organically friendly than rock salt. Anyway, get two to four of those. In the paper I read by Dow, who make, or I don't know if they make it, but they're certainly the authority on exchange resins. They said a reasonably strong salt solution. So it's open to interpretation, and you need to experiment a bit with how much salt you use. And then what you need to do is, when you've dried the filter ingredients out, is you need to soak them in a salty solution, or pass the salty solution back through the filter a few times, which replaces the sodium ions. So what I'm doing is I'm just preparing a bowl of salty water, and I'm going to soak the filter solution in it, which is the carbon, activated carbon, and the ion exchange resin. There's a spoonful of salt. That's about 2.5 dessert spoons. I'm just filtering some water for the kettle because I'm going to use hot water to make the salty solution. It's just household tap water going in there, straight from the tap. See, it just fills up the top bit, filters through the cartridge, and just drips out the bottom bit, basically. So I'm going to make a cup of tea with what's left of the filtered water in the kettle. Then I'm going to refill the kettle, and I'm going to make my salt solution. So I'm just taking my bag of resin and carbon granules, which I salvaged from the Brita filters. Just cut them open with a kitchen knife, basically, and empty the contents into a food bag. I'm just going to put that in the washing up bowl. I want it to be hot. I want it to be 100 degrees C, so it activates the carbon and the exchange resin with the sodium solution, and then regenerates it. Then you can reuse it. And I got this information, by the way, from a PDF which is online from a company called Dow, and I'll include the link in the description below, and I'll show you that as I do it. It's not easy to hold the phone and film both hands at the same time, obviously. And there's the yummy water filter solution, the granules. That's carbon, granules and ion resin, ion exchange resin they call it. I'm just going to call it resin from now on, you'll know what I'm talking about. Obviously if you've dried it out at 100 degrees C and it's thoroughly dry, and then you've put your salt in the bowl and then you've added your resin, now all you need to add is boiling hot water to make a salt solution, and that regenerates the resin and the carbon apparently. So I've just added some more salt to that. There's about 3 dessert spoons in there. All I want to do now is add a whole kettle hot boiling water. Basically it's the carbon and the resin in there and the salt, sea salt. I can empty the whole kettle because there's no lime scale in there because it's filtered water, and there was a fork in there which I had to retrieve, which was rather hot, but basically all I'm doing, the spoon's still a bit hot, ow, ow. Okay, let's go back to the fork. Basically all I'm doing is just stirring around the boiling water, or the near boiling water because it's not quite boiling obviously. And I'm melting the salt, so we've got a nice strong sodium chloride solution that is actually regenerating the ions in the resin and the carbon. And it's as simple as that really. Then you just need to drain the water off, the salt water off, dry out the resin, and it's good to go again. Dry it out to about 100 degrees C, 105 degrees C, and it's good for at least another 4 weeks of water filtering. Inexpensive, easy to do. You can do it with the stuff you've got at home. So that's the hot water and the resin and the carbon. 50% resin, 50% carbon, so it's 1 part resin, 1 part carbon, if you're not into rocket science. I've given that a nice stir around, and I'm just going to leave it to soak for about an hour, and that will complete the regeneration process. So that's all there is to it. It's inexpensive, it's easy to do, and you can do it with the household products you've got around your home, and you only need to buy 1 or 2 water filters, or buy the ingredients online, buy the activated charcoal and the ion exchange resin, which you can easily buy online and they're inexpensive. You can get like a litre or a kilogram of each for about £30 UK, which is about $50 in the US. And then, which is what I'm doing, make your own water filter, and I'll show you how to do that as well. That's going to be part 3, because I'm good like that. I've got that little lens flare chasing me around, look.